guys, Mr. Gucci here with a help video for the ideal gas equation worksheet, all right? So we're going to start off on this video doing numbers one. Well, let's do number one to start with, all right? So as you know, you put your name in here, David, David. And my ID is blah. All right, you of course will use whatever your ID is and get your own unique set of problems. All right, so let's get started with problem number one. What would be the volume of 1 mole of gas at 1 atmosphere of pressure and a temperature of 273, that should be Kelvin, 273 Kelvin, fixed. All right, so let's figure out what this is. So we need to use our gas law equations. Now, there is one gas law equation that we're working with in this homework, all right, and it is this, all right? Let's see here. Take the pressure of any gas times its volume and divide it by however many moles there are times its temperature, and you get a constant. The gas constant. It does not change. And what this means is that if you have any three of these values, you can find the fourth. In this case, problem number one, all right, what you have is you have the pressure, 1 atmosphere, you have the temperature, 273 Kelvin, and you have the number of moles, and you are trying to find what the volume is. All right, now there's an easier way to run this equation, and it's by rearranging it to look like this. All right, rearranging it to look like this. Basically, we're just going to bring temperature and number of moles over, creating an equation that looks like this. The pressure of a gas times its volume is going to be equal to the number of moles present times the gas constant that we're using times the temperature. Now, what I love about this arrangement of the equation is the thing that all students have loved since the invention of gas laws. There's no fractions here. All right? No fractions. And as we know, we freaking hate fractions. Fractions suck, all right? Sucks to solve for fractions and variables and so forth. So we rearrange the equation. We still are basically using the same equation, just rearranged. So let's jump in and do this problem now. So I'm going to set this problem up, okay? Here I go. The pressure of the gas, by the way, I expect you to do this. The pressure times the volume of the gas is equal to the number of moles present times the gas constant times the temperature. And now we just plug in what we know from the problem. So here I go. Plugging in from the problem. Where you at? Where you at? Where you at? Here you go. 1 mole of gas, 1 atmosphere of pressure, and a temperature of 273 Kelvin. All right, so plugging that in. So the pressure is 1 atmosphere. All right. We're trying to solve for the volume. The number of moles is 1 mole, okay? The temperature is 273 Kelvin. Now we're left with the R value. It's a gas constant, but there are many different gas constants that exist, all right? How can there be many of them if it's supposed to be constant? Well, listen. It depends on the variables that you use. Specifically, it depends on the pressure unit that you use. All right? We're using atmospheres in this problem, so we need to go with the gas constant that also uses atmospheres. So I'm going to go here. I wrote it down on the sheet. Here we go. 0.0821. That is the gas constant when you're using atmospheres. If we were using kilopascals, it would be 8.314. And if we were using torr, it'd be 62.36. But here we go. 0.0821. 0.0821. All right, so here we go. 0.0821. 2, 1. I got a stylus, so I'm not writing with my fat fingers. Okay, so let's solve for the volume right here. All right, let's solve for the volume right here. We're going to divide both sides by 1 atmosphere. Did I say I don't have fat fingers? I spoke too soon. 1 atmosphere. So it cancels out. And so we have to divide by 1 atmosphere here as well. Okay? So now this is what we have to solve for. 1 times 0.0821 times 273 divided by 1. Well, multiplying and dividing by 1 is totally pointless. So we're left with 0.0821 times 273. Let me go to the calculator and figure that out. 0.0821 times 273. And I get this number. Ready, ready, ready? The volume that this gas takes up is equal to 22.4 liters. All right. Now, for reasons that I'll talk about later, this is an important number to mention. All right. What we figured out is that at 1 atmosphere of pressure and 273 Kelvin, 1 mole of gas will take up 22.4 liters. Doesn't matter the type, but 1 mole of gas will take up 22.4 liters. That's an important number that we mentioned in class, and it's going to come up again in this homework. So, bookmark this, dog-ear this, write this down. All right? Write this down. At 1 atmosphere and 273 Kelvin, that's 0 degrees Celsius, by the way, 0 degrees Celsius. All right. 1 mole of gas takes up 22.4 liters. That's an important fact to remember. All right, let's plug it into the answer sheet and see if it goes. All right, 22.4 liters. Fantastic, fantastic. All right, there we go. Awesome. I hope this helped. This was a longer video because I was introducing the concept. It will speed up in the next ones. All right, good luck.